Okay, welcome back, and now we're going to do another example. So let me read it, and then we'll jump right in. It says, a particle moves along a coordinate axis in the positive direction to the right. Its position at time t is given by s of t equals t cubed minus 4t plus 2. Find v1, v of 1, and a of 1. So find the velocity of the particle at t equal to 1 and the acceleration of the particle at t equal to 1. And use the information to answer the following questions. Okay, so let's do this. Let's find v of 1 and a of 1 first. So let's find the velocity. So we're going to take the first derivative. So v of t equals s prime of t, which is going to equal 3t squared minus 4. And then a of t is equal to, well, v prime of t, which is equal to s double prime of t. So now we're going to take the derivative of v. So the derivative of v is what? 6t. Okay? So now we want to evaluate this at 1. Well, so that means v of 1 is equal to what? 3 times 1 squared minus 4, which equals negative 1. And then a of 1 is then equal to what? 6 times t. So that's going to be 6 times 1, which is 6. So again, do we have a context in this problem? No, they don't give us a context, so we have no units. So okay, now here's the question. The first question says, is the particle moving from left to right or from right to left at t equal to 1? Okay, so now, what is the information they give us? The particle is moving along the x-axis in the positive direction to the right. Its position at time t is given by the s of t function. Okay, now, if you look at the velocity is negative 1. So if the positive direction is to the right, then the negative direction is going to be to the left. Okay? So what's the answer? Since it's negative, it's going from from right to left. So it's going to the left, or in this case, we want to answer right to left. Okay, now, that's it. That's the answer to part A. Now, part B says, is the particle speeding up or slowing down at time t equal to 1? Okay, well, in order to answer that question, we have to look at the acceleration. Because remember, acceleration is change in velocity. So whenever you're increasing velocity, that's a positive acceleration. If you're decreasing velocity, that's a negative acceleration or deceleration. So in this case here, 6 is positive. So what does it tell us? It tells us that it's increasing. Okay? So, oh, by the way, we also have to look at this. It's increasing in the, well, let me see what they're actually asking. I just want to make sure we don't answer the wrong question. Yeah, so here's the thing. Got to be careful of it. Again, acceleration is positive, okay? but this is positive in the opposite direction of the velocity. So the velocity is going to the left. Acceleration is accelerating to the right because it's positive. So when you look at velocity and acceleration, got to be careful. The acceleration is increasing, but it's increasing in the opposite direction of the velocity. Okay? So that means the particle is going to be slowing down. Okay? Now, if the acceleration and the velocity have the same sign, then you could say that the particle is speeding up. Whatever direction, that's irrelevant because, again, it's going to be in the same direction. So if they're both negative or both positive, you could say that the particle is speeding up. If they have opposite signs, which means acceleration and velocity are going against each other, the particle is slowing down. And so in this case, the answer would be the particle is slowing down. And that's it. Okay, so again, just be careful. It's not enough just to look at acceleration and say, well, since the acceleration is positive, it must be speeding up. Okay, or if it's negative, it's slowing down. Okay, remember the negative sign, the positive and negative sign is about direction. Okay, whether it's slowing down or speeding up has to deal with the relationship between velocity and acceleration. Okay, that's it. Have a great day.